Hi everyone, and welcome to this webinar on GPR data processing and analysis. Thank you for attending. We'll be doing more of this in the future. Hopefully, that more people from other regions can attend. I would like to show you a little bit an overview. These are the points that we are gonna discuss. Let's start with a brief introduction, as I'm doing now. Then I'll explain some of the topics we're going to touch within GPR slides, like horizon mapping, topographic corrections, and vector imaging, and also within GPR Insights, our data processing flow, and also some workflows that we are working on GPR Insights and our whole ecosystem that is web-based. And then we will finish with 10-15 minutes of questions and answers. So today I have, just introducing myself, Dr. Alex Novo. I'm head of product management for GPR applications with Screening Eagle Technologies, and I have the pleasure to share the stage with Dr. Dean Goodman, which actually is a mentor of mine. I met Dean back in 2006, and we've been working together on GPR slides and some projects collecting data in the field, several archaeological projects all around the globe. We gave many workshops during the past years, and hopefully now that things start opening, we could do some in-person workshops in the future in different regions. And yeah, Dean is the lead developer of GPR slides. So I will be talking more about the GPR Insights portion, although I'm going to be touching some points on GPR slides briefly, more introductory ones, and Dean is going to focus on advanced features. As you may know, Screening Eagle Technologies acquired GPR slides last year in November, and we now offer both as one package, one subscription. So you have a web-based and a desktop software package for advanced GPR data analysis and visualization. We are trying to be more intuitive with GPR Insights and keeping the whole offering agnostic, so you can use it with any dataset from any GPR manufacturer. Versus silo solutions that might only give you the possibility to upload a type of proprietary data. So Dean will start with horizon mapping. So here, just a quick introduction from my side. This could be useful for different applications. One is in road analysis, asphalt or pavement layers. Also in geology, could be used even in archaeology. So in bathymetries also, he will be showing some of those examples. Another important piece of the software is geometry, right? I mean, how we account for warping objects that have not a flat geometry, but a complex one, like in this case, this arch on this bridge. So he will be talking about that, and that's part of the topographic corrections and vector imaging pieces of the software in GPR slides. Then I'll be talking more about GPR Insights, like an introduction, how we do the basics of GPR slides within GPR Insights. Basically, we streamline some of the processes for those that are very familiar with advanced processing in GPR slides. They might have heard about the blue box, so similar to the blue box, where we are bringing years of experience on how to better processing any data set that you might have and generate 3D imaging immediately, that then you can also edit. And then we will be showing some of these workflows that we are working on our web-based ecosystem. So I'll be showing how adding more context, more data. Not only GPR data is key for proper data interpretation. So I'll explain this for especially for those that are not familiar with skinning eagle technologies. I think this is something that might be of interest, and some of our customers actually might not be using yet GPR inserts or know how to access completely. So I'll be explaining a little bit of that, and then finally we will have questions and answers session for both GPR insights, what I'm explaining, and Dean's part on GPR slides. So I hope you enjoy this, and I'm gonna proceed now with Dean's part. So Dean, your time, please.
Hi, I'm Dean Goodman, the lead developer of GPR slide software. I'm here with Alex Novo, and today Alex has asked me to introduce horizon mapping in GPR slice software. We're also going to look at topographic adjustments in GPR slice, as well as briefly introduce vector imaging. We're going to go in to do horizon mapping. You go on the static menu, and the menu called static horizons is where we do all the mapping for horizon layer picking. You choose whatever folder you want to work on, and then you hit the button called Detect Draw Horizon. And here's a small project that we have. Now, there's a lot of buttons in here. We're not going to get to all the buttons, but we're going to show you the major features in this menu. Normally, we have to choose horizon number 1, which would be the ground surface. And for this particular data set where the data was recorded right on the ground, the antenna was on the ground, the ground surface is right at the top. So we'd have sample start, it would go from 3 to 3 and on horizon 1. We just auto detect that, and you can see we set the surface up here. But you can imagine if we had a drone survey or the elevation was changing of the antenna off the ground, we might have a variable surface. So horizon 1 can also be a variable surface. And then once you set that, we probably want to run this in batch. We'll just run that in batch. Okay, so we just ran it in batch on all the profiles in this project. The next step is let's say we want to detect this horizon there. We go to horizon number 2, and then we set a sample start and a sample end. Right now it's set to 170 and 300. But we hit this button here called horizontal search bars. It can say that we're searching just in that location of the radar ground. Okay, we can set it to work on the peak plus response of the pulse or the peak minus. Right now it's set to the peak plus, and we'll just run an auto detect on it right here. And you can see it did a reasonable job on detecting the horizon here, but there are a few areas where it lost the horizon. It could be missing. We have what's called a moving filter, and you can set a filter length. Right now it's set here to like 11. And you could put a filter length that would take the moving average and reset anything that went above a threshold of 1 sample, would set it back to this moving average. So if we run that, we could do something like that. And that looks like it has a nice detection on there. And if you put a sample length here that's really long, like let's say I made it too long, and I auto detect, it might make it too flat. So you have to trade off smoothness with the detail in the profile. So I'm just going to go back and put it on 11. Okay, so once you have that set, we can run this in batch on all the profiles. So I'm just going to do that now. And then we'll go back and look at the second radiogram here. And here you can see that we have a horizon where it's not perfectly continuous. So we can either come in here and edit it. So there's a way to edit it. You could come in here and say, I want to edit it. And if you do that, you can move this down here. Now, your pen resolution is actually decided by this thing called length. Right now, it's set to 50 scans, so it's doing a kind of a large swath of data. Let's say you want to have more detail when you're editing it. Let's say if I put it down to 5, and then I come here, you have a lot more detail that you can put into the profile. So it's your trade-off of what kind of resolution you want to put into your profile. Okay, I'm going to put it at like 15, and then just edit this right here. And then let's say I like that. Okay, You could do that. But there's areas where we don't even have a horizon. So what you could do is you can actually come back here and erase locations on that horizon. So you can say edit, erase, and then you can take out areas where you don't have data. Okay, you could do something like that. Okay. So that's another way to describe that horizon. And down below is actually the layering model. Now notice in the horizon menu, you have a velocity. So each layer is going to have its own velocity. And that'll describe the actual geologic map down below here. Let me go back to the first profile here. And let's say we wanted to detect this third horizon down here. So I would come over here and put this on horizon number 3. And then I'm going to show up that filter and just try to detect it right here. Put that at 0. And then, so right now, it didn't do such a great job right there. So we could put on that filter and see what it does. So it didn't do such a fantastic job. It missed it because it got a little bit weaker here and we had some reflections come down here. I can try the peak minus response, which would be the black part of the pulse. And here it found that over this range of the data that, yeah, it got stronger down here. So this one's a little trade-off. Let's say I wanted to just detect the white. So I'm gonna go back and detect the white. And I can edit that, but let's say I want, even though I'm detecting the white, but I want to move up the horizon to be launched at the beginning of the black, or the beginning of the initial part of the pulse. I can actually come over here and put in a value and detect it, and it'll move it up that number of samples. Let me go back down to like 30. Okay, and then let's say I wanted to edit that. I would just come over here and put a longer length here to make it a little bit quicker, save some time. So I could come over here and edit it. And we're just going to draw that quick. And then I would save and edit it. Okay. But before you would come in here and edit each one, you'd actually come and run this in batch. So I'm going to run this in batch right now on all the profiles. Okay. And without having to go back and, well, let's say I just want to edit one. I just edit the first one here. And I'll redraw it, and we'll just resave that. Okay, we save that. Let's say that's good enough. Okay, so we have these 3 layers. Just to let you know, in GPR slides, you can actually detect up to 15 layers and assign all the different velocities here. Just to show you that these velocities are active. Let's say I were to increase the velocity here to like just a crazy velocity of 20 centimeters per nanosecond and redraw that. You'll see that this layer got a lot thicker. So this is the actual geologic model. And this is the actual, just the picking on top of the radiograms. I'm gonna go back and put this to what it really is, and about 11 centimeters per nanosecond. Okay, so once we have that taken care of, we can actually now compile these horizons and get them into 3D. So in the previous menu, we come over here and we compile horizon number 2. And we don't compile horizon number 1 because horizon number 1 is just the ground surface. But what the software does, if you only have 2 horizons on a project, which the horizon 1 is the surface and then some subsurface, the software will actually copy horizon number 2 to horizon number 1 for convenience, because otherwise it's just 0. But I'm just going to compile this. And GPR Slice compiles a lot of different data. And there's a bunch of different files, and I'll just briefly explain them. Horizon file is the actual sample number of the pulse that we detected. Okay, and then horizon depth is the actual depth of that horizon based on your velocity model that we had set. Okay, so if you came and changed your velocity, you don't actually have to redetect anything. You just put in a different velocity and compile. Horizon elevation is the actual elevation, and then the thickness would be the thickness of that horizon. When you're just looking at the second horizon, the thickness is the same as the depth. But if you can imagine, if you're looking at the thickness between the second and third horizon, the thickness would be just the thickness between the second and third. So, and we also compiled the amplitude, and there's an export file which you can actually put into other software, and you have all this data in one file. And we also had a request over the years where that data that's compiled is on every scan in the profile. So you can imagine if you have a 50,000 scan profile, you have a big ASCII file. There's an option here to actually re-export the data to a linear length on the ground, like 1 meter or whatever. And it'll make another export file for you, and it'll reduce the data, but it'll also give you some statistics, and we'll show you that a little bit later. Right now, we compiled Horizon 2, and now we want to grid Horizon 2. I'm actually going to compile Horizon 3 at the same time here. And there's Horizon 3. And then we're going to go grid the horizons here. And then we got Horizon, we got 3 slices, and we'll shut off multi-thread, and we'll just let these run. And you'll note that when Horizon number 1 comes up, it's going to look identical to Horizon 2, simply because for convenience, we copy Horizon 2 to Horizon 1. Okay, and there's Horizon 3. Now it's working on Horizon 3. Okay, so from here, we can go into OpenGL and look at these data. So we'll maximize that. We'll put up a profile, and we'll make it a little bit larger. Okay, and then I'm going to store that to the screen. Then we come over to here, and we can choose Horizon 2. And there's 3 buttons here. Horizon, if you hit H1, it'll just give you the color palette that you have for the horizon. I'll just hit that. And that shows you the color palette that you have assigned in the options menu. There's also an option to put on a net, which if you choose different densities, you can get a different density of net plot over there as well. And then the H2 allows you to have a solid color. And the solid color will take between 1 and 256 color values here. So on color 78, if we hit that, it'll create a solid horizon and has a light switch on. So lighting is actually being applied to that data. And if you shut it off, it doesn't look very good if you're using a single color for that. So I can leave that on there. I'm gonna go back to H2 here, and then I'll store that. And then if we want to put on the 3rd horizon, we come down to the 3rd horizon, and then we hit the, I'll use just a net plot. And there's the 3rd horizon for us there. Okay. What I'd like to do is show you another feature in the software. And what we'll do is we're going to go to a different project real briefly. And that would be Kasachi Tilt, I think. Yeah. Let's go there. There's a feature in GPR Slice where once we have a horizon, we can actually make that horizon flat. And many years ago, we used to work on burial mounds in Japan. And let me just open up a PowerPoint here real quickly for us. We used to work on burial mounds in Japan, and some of the contour maps were very low resolution. We only had 1 or 2 meter contours. And we knew at this particular site that we were working in that there was a flat layer of volcanic ash. And so we could actually just detect that flat layer and then do what's called a horizon correction to make that flat. And we could actually get closer to topography than we could in digitizing these old maps. This is data taken back 25 years ago. So here's this particular data. So you choose your horizon here, and then you run this option here called horizon correction. And I'll just have to scroll down to show you that there. So what that does is it takes whichever horizon is active and makes that horizon flat in the data. Okay. There's one other feature I'd like to show you. And I'm going to go to another project. We're back to the other project here, Horizon. And it's called the depth radargram. So we're going to go back over to here. And you know, all our radargrams are recorded in time, and they're not recorded in depth. So this axis is really time. Often you'll see, and we do it as well in GPR Slice, we actually put a time labeling on the left side or a depth labeling on the left side, but that's just apparent depth. If you have multiple velocities on different intervals or interval layering here, then this depth axis doesn't really mean anything. And you can't just put it in one location. You'd have to put it in all the locations because the horizons are variable. But we have what's called a depth radargram. And what that does is it adjusts the radargram to match the horizon thicknesses and the velocities. So if you hit depth Okay. And if we go down here, so this is a radargram that's actually corrected from time into depth. So if you notice, these layers are there's actually, the bottom layer is actually, it's variable, it's not flat. So in this particular data, which is the info depth radargram, there's no time in this. This has all been converted to depth. So having a time scale wouldn't mean anything. You have options where you can run some of these features in batch and actually adjust all your radargrams to actual depth. Okay, I want to show one more project when it comes to Horizon, and just to show you what you can do. And this is a drone survey, drone bathymetry. And this is collected on a frozen lake in Sweden. And this is where the drone was going very close to shore and then going out towards the frozen lake, coming back to shore. And we'll show you the track in a minute. So this is the actual detection, and we had to edit it a little bit with the mouse. And then we're going to go here to OpenGL. And let's see if we can recall that data set. So here's the actual site here. And we can actually put on the actual track of the data. And that's all tracks. So that's the actual track, what they programmed here. And they programmed it to fly at a level elevation. And from there, we actually compiled the bathymetry, or the horizon, and that would be Horizon 2. And there's the actual bathymetry of that of this frozen lake. It's very unique that they were flying at a high elevation, but radar waves are just so unique that if you have frozen fresh water, you can get radar waves through the frozen lake and actually get down to the bathymetry at the bottom of the lake and actually get returns that you can process and do bathymetry from a drone. Okay, that's all we want to talk about Horizon. And next, we'll be talking about topographic adjustments in GPR slice software. Okay, to do topographic adjustments in GPR slice software, we go to the static menu and we go to static topography. And there's three major kinds of ways that we can create topographic adjustments into a project. One, we can actually draw the topography and correct the data, where we actually draw the topography with the mouse. Another is where we actually import a digital elevation model and then use that model to adjust the data. And thirdly, we can use the GPS information on GPS projects and use that information to adjust everything to topographic adjustments. Okay, we should like to show you how we do put topography in there manually. So you'd actually just come in here and draw whatever you wanted, and then you would hit topo correction. And you could do that. And you could do that on every profile. This menu isn't really used very often anymore, but it does exist. What is more common is actually to use topography, import a topography.dat file, which is your digital elevation model, which is in the DAT folder of the project. And it's just a simple X, Y, Z comma delimited file where X and Y are your location on the ground and Z is the elevation. And just one important thing is when you import that, the Z elevation is based on the depth axis, whatever you have here. So this particular project is going to get imported with meters. So all we have to do is import it, and it tells us the min and max, and this has about 3.8 meters of total relief on the site. And next we grid that data. So we'll just show multi-thread here and grid that. And one important thing is that the grid search radiuses, blanking radius, and particularly the grid cell size and the start and end point should all be the same as your 3D volume. So there's our digital elevation model. And then the software says we can exit to OpenGL topo volume warp. Basically, we can just take that grid map and then do real-time warping into topography. So we come on this, well, we'll show you what it looks, here's what the data looks like without any topographic warping, okay? And in our radargrams here, how they look. And now we're just gonna go to the static menu and do real-time warping. So you can put on a little bit more vertical exaggeration if you want on the data as well. If you hit the step minus button, you get what we call ZT, or topographic slices. There's also an option to hit what's called ZL, which are real-time horizontal plane layer slices. So these are plane layer slices, which is doing real-time and cutting through this warped volume. You can also click on your radargrams, and all the radargrams will be real-time warped into topography. Okay, we can store that. Let's put on a Z level slice somewhere and store that. And we can also put on an isosurfaces. And isosurfaces will also get warped into 3D as well, into the topography. And for the isosurfaces, if you want to take away some of the top surface reflections, you can say, oh, well, let's start the isosurfaces at around 10 nanoseconds, and you'll be able to take off some of the top surface reflections and look a little bit deeper in there. You can store that to the screen, and you can also get on the topographic grid. We can put that on as a net. So you can have that all there in 3D. Okay, so that's basically how we do import a digital elevation model and then create and adjust the data in topography. There's one other thing I could show you here, that there's some people that also want to have those data corrected into binary files, where they actually put the topography into a new written binary file so they can look at all the profiles in the radar icon menu. So what we could do is, we did step 1 and step 2. What we could do is extract the topography files from the grid file. So I'm just going to do that. So what that did is that it made individual topography files for each profile. And then we go to the correct menu, and it already has the elevation there. If we hit topo correction, it'll actually do the topo correction on that. But we want to do this on all the data. So I'm just going to run this operation called batch, which is going to correct with standard topography on all the radargrams in batch based on that digital elevation model that we have. So please note that these are actually writing new binary radargrams. And we have these new binary radargrams set to have a new digitization of 500 samples. The original data, before it's corrected for topography, only has 292 samples. The software actually, once you have a digital elevation model, it recommends that the minimum sampling you should have on these adjusted data is 469. And that means that you won't cut off on any of the bottoms off on the data. But some people may not like this kind of look here. And if you want that look to be cut off on the bottom, you can actually set this to a lower value. So it just completed that batch process. Once we completed that batch process, we hit this button here called Create Info Topo. And that's a new information file that we have to have if we want to look at those data in 2D. So we're going to come over to here and click on the Info Edit Topo. And the Info Edit Topo only applies to the topo folder. And let's say I want to look at 12 radargrams by 3 rows, 90% of the screen. Please set a radargram. That will put that on the topo folder, sorry. And there we have all those profiles with topographic relief in 2D and their binary recorded data. Okay, next I would like to do a GPS project. So we're going to go to a GPS project now. Yeah. Okay. So we go to static topography, and we go down here to the step 1, which is extract GPS vector topo. And what that does is, for every profile inside your project, it's going to compile the third column, which is the elevation of the GPS. So we compile EC northings and the elevation. And particularly if you have good enough GPS, you can use the GPS as your digital elevation model. And so the button here just goes into those files which exist in the raw folder for every project and compiles all that data. And with that, we then grid the digital elevation model from GPS. And I'm actually going to change the blanking radius here where we're only going to search out 1 meter. And With that, you'll be able to see the actual track of the GPS over the site. And that's almost finished. And that's showing the track of the GPS. Well, we wouldn't want to create that digital elevation model. So we need to really fill that all in. So I'm just going to put in a larger blanking radius and let this run one more time. And just to note, the topographic grid has to encompass all of the data grid as well. So usually the blanking radius should be slightly larger than the blanking radius you used for creating the 3D volume. So there's our grid has been made. And then it says exit to OpenGL topo volume work, where we do real-time topographic corrections. And we can actually put up a picture of the site. This is a site in Indiana, a Strawtown archaeological site. And there's an Indian dwelling on the site. This is a platform. And that's showing the elevation there. And again, the ZT are the topographic slices. We can actually put on the ZL, which are the level plane slices. These aren't quite as interesting, but it's slicing through the topography. And you can also put on the topographically corrected radar graph. Now, this particular site, this is like a 23,000 scan profile with only about 200 samples in the depth. So that's good enough to get an OpenGL. But if you had a 100,000 scan profile that was digitized at 1024, it probably wouldn't render completely. We do have this option here in GPR Slice where if you have a large profile and you want to look behind the profile or data inside here, you can actually choose a scan length. Let's say I chose a scan length of 500. You can hit R+, and then hit this bounce button, and you can actually see how the data was recorded on the site. And you can actually change the length of this to whatever is a convenient length so that you could see past it. And you can actually hit the button called Store and see this continuing on, and you can rotate it around. And if you wanted to store that one part, you could store that part. I just hit the Store button again. And then so you could look at the different parts of the data more conveniently. Okay. And I'm just going to stop that and just put up the entire profile again one more time because it looked very impressive there. Okay, so there's the using GPS for the GPS elevations to create the digital elevation model. Okay, in terms of topographic adjustments, those are the three ways to do it. You can draw topography, you could import a digital elevation model on a local grid, or you can even import a digital elevation model on a GPS grid because the GPS wasn't working well enough, or you can use the GPS information. Okay, what we'd like to do now is we'd like to move on and just introduce vector imaging to you. Just as a quick introduction to vector imaging, back in the mid-90s, we started to do correct for the tilt of the antenna on a site. Our original data was where we just would do standard topography and just shift it vertically. And then we started actually accounting for the 2D tilt along a profile. And here's an image from the mid-90s where we actually adjusting for the tilt. But when you work in 3D, it becomes a vector correction or vector imaging. And when you're working particularly on sites with changes in elevation and the antennas connected to the surface, you have strong tilt in three directions, or the yaw, pitch, and roll. There was actually a university, McMaster University, back in about 2010, 2011, they actually put a tilt sensor on their antenna, and then we used a GPR slice software to put all that data into its vector space. Let's go to a site. And what I'd like to do is just a quick introduction again, going back to this project where we had in 2D space, if you recall this, we did OpenGL real-time warping on a project. We can actually, based on the surface normals to a site, we can actually generate the vector. And this is assuming that the antenna is exactly locked to the ground. And because we didn't have tilt meters on this antenna when we collected this data. So, but we can assume based that the antenna's surface, based on the surface normal of that antenna, we can actually create the yaw, pitch, and roll, or the vector. So what we do is we hit this button here called Generate Topo Vector Normals. And that'll actually create a new information file called info edit v for vector. And then if we come back into our menu and we hit the radargrams here, these radargrams are actually adjusted for the vector on that topographic surface, and you can see how things are. So a 2D radargram actually becomes a 3D surface actually. And we can, well, I'll just hit the store button here to get a few of them on there. Any event, and you can also put the original topography on top of that. So that's actually using vector imaging on a mound site and getting your radargrams into their true space. In a GPR slice, though, people are mostly working with regular geometries. And we have a lot of menus to assist you to actually create the vector. And one of them I would like to get to is longitudinal plus radial. So here's an example of of data that is taken on a tunnel. And we'll just go, so these are longitudinal tunnel profiles. And these are also mixed with the radial profiles along the tunnel. Okay. And we have menus that will actually help you set up these vectors. We're not going to actually run through those menus, but these menus exist right here. There's the vector radial tunnel warp, and there's a bunch of instructions on how to create the vector for radial tunnels. And there's another menu over here, which is vector longitudinal tunnel warp, that shows you how to create the vectors for those kinds of data. And if you look at, for instance, the profiles and the GPS files, which have the vector information in the 9th, 10th, and 11th column, you can see that these vectors are complicated. This is for the radial. And if we're looking at some here by memory are just the longitudinal, that we have a much simpler vector looking recorded there. There are people that have actually generated with their own script and adjusted those vectors to solve really difficult problems. If I can just show a brief example, it's right over here. Oh, it's hidden there. And this is a data set that was done by Guido Tronca and Gianluca Catanzariti in Italy. And it's showing a bridge in Italy and one of those arches, and they put all the data into its vector space. So they had to measure these arches exactly, and they wrote their own script to actually adjust the vectors in GPR slice so the data could be completely imaged. So these are showing all the vector radargrams that were generated on that site. And once they had the radargrams in vector space, they actually chose their utilities and rebar and structural supports in the vector space. And the data that's in orange are actually 3D volumes made from the vector radargrams. So to date, I think this is the most largest vector project that anybody's ever done inside GPR slicing. We're really lucky that Guido and Gianluca have put all the time and effort to generate all the vectors to do this. Okay, I'd like to show some other things that you can do in GPR slice with vector. And going down here to vector. This is it. If you have enough radargrams, we actually have a menu where you can actually interpolate between radargrams. It'll interpolate between radargrams and also interpolate between the vectors. And then you can create a solid 3D volume from the vectors, radargrams. And here's a solid cone or a half cylinder of data. And we'll just put this on solid here in a second. And it'll fill up completely here. And so this was data that was collected with radargrams that were only made at about 0.5 meter on this radial site. And then we interpolated them maybe 30 times and then compiled all that data into a 3D volume. So that's also available for you as well. And I have another project that a friend of mine in Greece had collected in Japan. And that was Pablo's vector 3. This might be it. And we're just showing you that you can actually have vectors that are not perfectly on a line. They could be in different orientations on the site. This is actually a burial chamber in Japan that Pablo's from Terra Marina actually collected. So you have to set up all these vectors inside GPR Slice, and you can display them as you will. I'd like now to just to really give a quick 4 or 5 minute introduction to really simple vector information that we did on King Tut's tomb. And there was a British researcher that believes that next to King Tut's tomb, or inside the tomb, that Nefertiti's chambers were either existing on the northern or western walls. And they collected data, and the problem with their data that we decided, there were several researchers that were involved in analyzing their data, that they just took data and they overgained it, and they interpreted data like this as saying that it had complete structures that were below the ground or below the walls, and there was also biologic material. And the National Geographic Society became a little skeptical of their interpretation, so they wanted to do another survey at the site, and we were part of the 2015-2016 survey group. And what we decided, and a fellow that's no longer with us, but was a top scientist named Glenn Dash and the Glenn Dash Foundation, he came up with the idea that the people at the NGS should collect data along the Treasury wall. And this Treasury wall would act as a calibration to calibrate all the other data that we collect on the northern and western walls. And here's the actual Treasury room that was opened up when Carter discovered that site. Here's how the data was collected with the equipment. They were on a track system, and they were limited to only collecting data in about several orientations at different levels on the walls. Here's the actual data that was collected on this Treasury room wall. So you see a strong reflection here, and then there was some other reflections here as well. We actually decided we wanted to simulate those data and to actually see what those other energy legs were in the data in that calibration profile. All right. So we actually have this set up over here. I'm just going to simulate this. I think we can put it on continue. So we actually did a simulation where we're including corner reflections, reflections that have a triple reflection, 4 reflections, and even 5 reflections. And it turns out that these reflections down here at depth are actually, this is a reflection that actually takes 4 reflections, one that comes out of the antenna, goes back to the surface, hits a corner, and comes back and gets recorded. And that's a really strong reflection. Some of the other energy is reflections that just takes 2 reflections back. So that's the simulations that we ran. And getting back to over here. So you can see that the simulated data looks pretty close to the original, to the actual data. Of course, it's great to understand these other energy legs in here, but the main energy leg that we're interested in reflection is just the inside wall of the Treasury room. Okay, so this is the reflection of the inside wall of the Treasury room. Now I'd like to go real time into OpenGL to show this data. And we're going to go to vector KV62. That's vector KV62. And I'm going to open this up and maximize that. We'll put on the whole data. Oh, yeah, we want to come over here. I'm going to put on all the bitmaps. In OpenGL, you can actually put up to 6 bitmaps that can be oriented vertically, horizontally, or any orientation that you like. Yeah, okay. So there's the western and northern walls and just the site map of King Tut's tomb. And then we want to hit the R button. So here's the actual calibration radiogram that we took on the treasury room. Now I'm going to store that, and then we're going to go to the back side, and then we're going to get the other profiles, and we're going to store those to the screen. This data were actually on the track system was only 5 meters, so they were limited to taking 5-meter data sets, and we're just appending them together. So if you look at these two data taken on this level of the wall, which is like 30 centimeters off the floor in King Tut's tomb, there's nothing that would look like anything that would look like a compared to a void space behind it. If we even go even higher up on the wall system, and now we're up at we're 1.5 meters, and there's nothing there either that would look like a void space. So we believe that there are no voids existing behind the western and northern walls. And our conclusions were also drawn by the people from the University of Torino. Luigi Zambelli and Gianluca and people from the University of Torino, they took single channel and multi-channel equipment on the walls, and they collected full data, and they found out that there's no hidden chambers at all. But just to let you know, this has not been rested yet. Even a 4th survey was done with Russian equipment, and then they had the same problem using low frequency equipment that's like over banding and has a lot of noise in the data. So the new Russian team is now claiming that there's corridors behind it. So the search goes on. In any event, that's all that we'd like to do on vector imaging, and we're ready to take questions later on after Alex finishes his introduction to GPR Insights. Thank you very much.
Thank you, Dean. Well, those were really, really nice examples. Just to let you know, we've been now seeing advanced processing with GPR slides, either the horizon mapping or topographical corrections and vector imaging, especially for these 2 cases, but also on the case that Dean was showing, the bathymetry. Before doing all these corrections, we first need to create a project, of course, and import the data, do some filters, and then what we do is generally a slicing and gridding and creating a 3D cube, a flat 3D cube that then you can do everything we saw that Dean was doing. So let me just take a step back and show quickly how we do that in GPR slides. So I'm going to use a project that Dean and I usually use for workshops, webinars, introduction to new subscribers. It's a small grid. So the processes are the following. In the beginning with GPR slides, I always say that. No, in the beginning you start from left to right and top to bottom. So the first thing, you create a new project. Here you choose the type of data. Then you transfer the data, right? Or you can copy paste here that everything would go to a raw folder, right? GPR slides creates all these folders for different processes. And then you create an information file. In this case, imagine somebody collected the data. I don't know exactly all the details, but I need to know what's the dimensions of the area they collected. If it is a grid, like in this case, what's the orientation or the spacing of the profile. So that's what we do here. We know in this particular case is a grid of parallel profiles collected at 0.5 meter. These are the dimensions. So I'm gonna make here a information file info webinar, and I'm gonna ask the software to read everything that is on the raw folder. So here I have all the profiles. As you can see, they're spaced by 0.5 meter. In the y direction, they have 10 meters of distance each. So then the next step following this top to bottom would be convert the data. Before doing that, usually what I do or I suggest is having a look at the grid plot. And here you can see the grid that we just created. Then we convert the data. We just remove the wobble here if there is some DC shift on the data. Then you can do this, or actually, if you go to the options menu, just to speed up processes, you can put here, we have multi-threading processing in GPR slice. So in my case, I have 12 logical cores. I'm going to put 12 here, select, then all the processes are going to go faster. Then the next thing you do is go here and put artificial markers. In this case you have GPS, you put you would select option number 4, GPS vector scan number. Then the next thing we usually do, we filter this data. I'm gonna choose the radar folder because that's the only data that we have from now is the data that we had on the raw folder. Now we converted to the GPR slice format and we have it under the radar folder. Usually we do spectra and gain here. This 200 or 250, I guess, megahertz antenna. We can create here this help set. So just quickly showing you all the steps until we get to the final 3D cube. Here we run the bandpass. Okay, this goes fast because I have it in MT multi-threading. Then maybe after the bandpass, you can do background or not. I'm gonna run it quickly here. Then you might do some maybe Hilbert transform to do the slicing and gridding over Hilbert. In case there are some hyperbola, maybe you can go to here and look for, actually, let me change, I have something the wrong color palette probably here, rather than, I think normal one should be 2 here. Search, okay, that's a little bit better. Maybe there was an area here that you can see, and then you do this, okay, and you select here the actually we can run migration here instead of doing, then we can do Hilbert on top. Let's do maybe migration here from the filter and do migration. We can activate even the processing graphics here and do migration. And then we can do on top, we can do Hilbert. And then after this, usually we do a slicing and gridding, like for instance here. Well, first of all, let's go here, select the 0 nanoseconds. We can do it automatically or not, or manually. Then I'm gonna do here, let's see, so we can do 50 slices, or I mean, we can do less, we can do 30. We can do an overlap of 50%, help thick, is to show you here on the Hilbert menu, show example. We can do something like that. And I'm gonna have a webinar. Just click on the slice, XYZ. Okay, and now we will go to grid and do the gridding. We can do here help set. We start gridding, and we're gonna grid the 30 time slices that we created. Gridding is completed. Now we go to time slice menu. We look for all our slices that are webinars. You can have many others, as you can see here. I was playing with this dataset many times. So we draw them all. As you can see in GPR slice, we can plot all depth slices in a single screen. Then once you are here, usually you do left click, create this pop up this menu where we run this auto gain all with all the histograms and then redraw. So we're going to create a better balancing of the distribution of colors between different slices. And then we go here and do this interpolation where we create in vertical interpolation, we create more slices for the final 3D cube that is being compiled now. Now it's done, and you go to OpenGL, and this is where when you start with GPR slice, this is the place where you want to get. You have to do the steps we did to get here. Now I want to show what we do in GPR Insights, and this was inspired, of course, in GPR Slice. GPR Slice has a quicker way to go when you are a little bit more advanced. You can set up your what we call the blue box here and set several parameters for all the processes that we did now one by one. So with GPR Insights, our web-based software, you can access directly from our website, screeningeagle.com. I'll show you here that we have some information. If you go to products, post-processing, analytics, here you can go to GPR Insights and GPR Slice, learn more. And actually you can request a trial of 30 days, free trial of GPR Insights. You can do it from here. Then if you want to access the software, let's say that you have an Eagle ID or not. If you don't have, you can go here to login. And if you don't have, then we're going to ask for some data. Then you can request a login credentials. Otherwise, if you do it through this button, try GPR Insights, it will happen the same. Pretty much me, I'm going to access the software since I have already a login. I'm going to click here and it's going to connect with our workspace. So workspace is our central hub for data. It's our data repository. I'm going to show you here. For instance, here on the left-hand side, you can see the applications, the apps that I have a subscription with. In this case, GPGS for GPR, and PD would be for the Pandit. This logo is for our software Inspect, and GPR here is for GPR Insights. On the GP and GS, you can see here many different projects that were collected by me or by colleagues, and then we can share with an URL. I can quickly import data here. And then, as I was saying, this is GPR Insight. So if I want to access, I just click here, a new tab is going to open. So this is fully web-based, as you can see. So as I was mentioning before, is agnostic in the sense of data coming in, any GPR data, and is independent in terms of platforms, so PC, Mac, and then there is no fragmentation in terms of browsers. You can use it on any browser. As well, here myself, I'm using Chrome, as you are seeing. Now I'm connecting to an instance to open GPR Insights, like a virtual computer, virtual machine is open in the software. Now it's going to load all my projects. Here I have a bunch of different projects. I'm going to click on new project and I'm going to import this dataset that we were seeing in GPR slides. Here is the freshman. So here in one click is going to create the project and load the data. I'm going to give this a name, freshman webinar, create project. Now, during this phase of creation of the project, it's gonna do what I was calling the blue box in GPR slides. So basically, with years of experience and yeah, basically years of experience using GPR slides, we can recommend some of the best parameters. Here you can see that the 20 lines for now, they are one on top of each other because we didn't give any information. But as we were mentioning before, let me scroll this down. These were 20 profiles that they were in the y direction, if you recall, and then they were distributed half a meter apart. So here I'm going to say, okay, it's 0.5. So the software is going to distribute this, and it's going to do the processing, slicing, and grading all in once. So you can see that the data is already processed. Here, let me show you the full, let me remove the lines maybe here on top, and just scrolling, you're going to see something similar to what we were looking at in GPR slides. You recognize the feature here. Of course, then you can edit. This is just to give you a first approach to the 3D imaging, so you don't have to remember all those steps that I did on GPR slides. But then if you want to improve this image, by all means, you have all the capabilities here to do it. So in this case, I'm going to select the project. Then, as you see, by default, we added time zero, wobble removal, bandpass filter, background, some gain, migration, and Hilbert transform, similar as what we did in GPR slides with this project. And then if you go to the tab volume 3D, I have it by default like an auto calculate. I can switch this off, and I can do my own slicing and my own grading. In this particular case, maybe I could reduce a little bit the cell size to make it looking nicer. I think for the other project, actually, we have 5 centimeters, and here it was taking 10 centimeters. So it's gonna redo the slicing and grading, and now we should see the C scan with a more defined, less pixelated, let's say, you see more smooth out. So this is what I wanted to show on this part, how something that, for an experienced user in GPR slides can take, like, I think it took, I don't know, 8 minutes. It's not a lot, but here you can do it literally in a couple of minutes in GPR slides to get to this level of basic imaging and processes of your filters. On the last part of my presentation, I would like to emphasize these web-based workflows for GPR that we are working on, and new workflows now. Many people are working on it and talking about it. So I want to show our approach here with just an example. It could be with other sensors, and we are working, as I said, on being agnostic as much as possible. But I think this is a great example that I would like to share with you. So if we go back to our website here, and in our website you can see my colleague Gorka here with the GS8000, and what you can see here on the iPad is data of an intersection. This intersection that is being now GPR data is being collected with our free path scan mode. You can see heat map, a time slice view in real time. Actually, then once you have all data collected, you can do a lot of things on our app. Let me just stop here and share my screen with the iPad. I have a good data set that I would like to show. Just 1 second here. So I'm gonna do this now, screen mirroring. So now it's connected, and I'll show you here. So now you can see on the screen, this is an intersection of data collected with a GS with free path mode. So everything is georeference, centimeter precise. And here, anyways, you can do, similar to what we were looking at in OpenGL or Insights scrolling on the CScan. You can put some tags, you can draw lines and do some exports already from the app. And then what is really fantastic from my point of view is that you can share from here. You can upload to the cloud and have it on a different environment. So now, for instance, if I go back to my workspace, let me share the screen again of my computer, and this is the same that project. So we can see, you can see some screenshots here. We can see information about the sensor, when data was collected, and all that. And then also we can bring this into GPR Insights. And if we bring this to GPR Insights, this is the project here, and we can actually let me remove here the lines, update this view, and remove the lines, right? I mean, and I can see pretty much the same. Here we use slicing and gridding. In this case, as you can see, I can add tags or I can import the tags that somebody already put in the field. So this is really nice because it can give me an idea of if somebody collected the data and then share with me, I can go directly to one of these points and see what my colleague was tagging. Then the other thing I like to show here is that we can import a deicer file, so, let's say an as-built. Now it's going to upload it on the CScan view, and now I can, come here and see if the data corresponds well with the as-built. If not, I can go here and myself also create an object. So you can draw lines in GPR Insights. Since this week, I wanna take this moment to announce that we are launching 1.3. So in 1.3, Insights 1.3, you have also drawing, and you can do here. I don't know. Let's create quickly a line here. That color, you can change the diameter of the pipe, and really quickly doing this drawing, and you can say done, and there's your pipe. So you can do all these and then export to DXF or Shape or KML, whatever you want, whatever you choose. So this would complete a final workflow of collecting data in the field, doing some interpretation if you can finish in the field, then off you go to the next project. If you cannot finish in the field for several reasons, or you want to double check with somebody from the field, even you can share a URL with somebody that is at the office and might have a computer and be in a better position to analyze the data. Then you can just upload the data here, and if you have access to an as-built as DXF, you can import it as you saw here, and then you can do your interpretation on top and export as one of these options that we have here. So I hope you enjoy this webinar, and we are now ready to take any questions you may have. Thank you.
Well, hi everyone, and thank you for attending. I'm here with Dean, as you can see. So there are already some questions
So yeah, we will provide on demand this webinar. So you will have information. Philip Galloway was asking about content after the presentation, and in terms of white papers, technical articles, we can share some. I'll give you my contact details later, and yeah, you can. I mean, I can share some of the information. Andres Trinidad, he's sending some questions about the GS8000. Thank you, Andres. You sent an email address, so I'm going to follow up on that. Yeah, also he mentions that content in Spanish would be good for people in Argentina. Don't worry about that. Half of the people working in Insights are from Spain, so we can do that. Maybe even Dean has some.
No hablas español.
No. Iván Rufino, hi Iván. Qué bueno verte por aquí. Yeah, I'll follow up with you on that. Ivan is asking more about pricing of our solutions, so I'll follow up with you on that. Colin, is there a master list of color palette numbers with visual examples?
Well, can I share the screen, or
you can share the screen? Yeah.
Are they seeing my screen?
No.
Can you go back? Oh, share screen. Okay. Oh, this one? Share. Okay.
Yes, maybe I remove this one.
I just moved to the side. So yeah, all your color palettes are right here in the edit menu, and you have 50 color palettes, and you can actually generate your own color palettes. You can also import a bitmap and still borrow a color palette, not steal a color palette. So you can generate color palettes in here as well. Okay.
Next question is anonymous attendee. We would love to know your name and last name about deicer polylines with elevation data from Insight. When we launched Insights 1.3 today, as I was mentioning, and you can create polylines and export as deicer. Then Jaime Plata, great webinar. Thank you, Jaime. Where could we see again? Is it going to be? Yeah, we will follow up and put something on demand on our website. See, I think, yeah, we exchange. Oh, yes.
Okay, yeah. How did you put in the tomb layout and wall murals in the GPR slice? Well, the tomb layout was made by the National Geographic Society, and they actually laser scanned it, but then made a drawing of it. So that was just the flat. And then the wall murals, I just got the pictures off the internet and just put them in there as bitmaps, vertical bitmaps inside OpenGL. So if I can go back in there real quickly, then I guess that's because that's vector KV62. And go back into here. Move this off to the side here, and I'll get all 3 bitmaps, and you can have 6 bitmaps if you want it. And I guess we got to bring that down here a little bit. Okay, so yeah, these were just images I got off the internet, and I knew that they went along the northern wall, and this was the western wall. So what you need to do is every bitmap that you have on there has its orientation, so you'll have to know the corners of each of these bitmaps. And here's the actual floor site map that the National Geographic Society laser scanned in, but then actually drew its location of where the tomb was. Okay.
Okay, Eileen is asking what is the long-term plan for GPR slice, and if it is being trickled into GPR Insights. Well, I don't know if that is the right word. I mean, the long-term plan is for now is a short-term plan that we are gonna keep as you are seeing. We have a single offering with a desktop software that is GPR Slice, as you all know, and as we are showing here. And then GPR Insights is our new web-based platform that is growing, being inspired by many things that Dean did in the past, and trying to modernize a little bit the interface and bring in some new things. Are there classes? Brian Thompson asked if there are classes offered to learn how to be efficient with this software. I mean, we have several tutorials on the YouTube channel, and we have several people around the world that would be willing to help. We have experts in Australia, David Hunter. We have Gianluca in Italy, and we have here 2 people that know. So let us know exactly. I mean, you can get in touch with us, and we can discuss these things. Philip, again, does GPR slice and GPR insights use the same processing algorithms? For filters, slicing and gridding, for the most part, yes. That could be the answer. Ivan says saludos, team. Okay, gracias. Saludos also from here, from Los Angeles. I was told that the scan limit for GPA 1100 is 100 square meters. It's possible to merge multiple 100 square meter projects into one large project in GPR insights. Yes, it's possible. I can follow up with you on that one thing, but yeah, it's possible. Anonymous attendee again. The webinar is great. Thank you. I'm new to GPR slides and found the webinar jumped into the deep end. Would there be tutorials for noise? Yes, and also my part when I show this freshman project, I put it there also for freshmen, for new people into the software, because we started with very advanced processing, as Dean was showing. But yeah, we can give you some tutorials on basics of GPR slice, and specifically my part was showing just the very basics with a very simple data set that we use often for this kind of practice of the basics. Can we use the GSA 1100? I guess it means the GPA 1100. We don't have a GSA 1100 for locate foundations about 1-2 meter depth. Yes. Yes, with the GSA 1000, you could do that. Yeah. Philip, are data outputs from insights directly readable by a slice and vice versa? No, we don't have like a format that. No, we don't have that. Can you move seamlessly between the 2 applications? You could move seamlessly. I mean, I guess you mean if you create a cube in GPR slice and export that to GPR insights directly, or vice versa. No, there is nothing of the sort for now. Bryce, hey, hi Bryce. Regarding the deicer import of as-built utilities in GPR insights, can the lines be color-coded, and are they changing in depth as you go down? Yes, you can. Yeah, that's exactly. You can test it now. It's live now. Insights 1.3, but that's exactly how we do. I mean, you can color code the utilities, and then if you change the tilt of that utility, is going to change also slightly the color appliance and lighting. So let us know how you find it. Anonymous attendee, does the iPad software and GPR insights offer topo correction? Does the iPad software and GPR insights offer topo correction? I mean, if you mean what you saw on this webinar with Dean, the 3D topo correction, no, we don't have that yet. Tanner Varisli, sorry if I don't pronounce well your name. We've seen GPR slice outdoor analysis. Or if are scanning indoor concrete, are we able to manage coordinates that we scanning on concrete or align pictures correctly? How does it work if I like to work with GPR slice for concrete scanning indoor? The same? Yeah, it's the same. Actually, the example that is here is indoor, right? Yeah. I mean, so that's an example. So yeah. So the answer would be yes. Thank you. Mustafa, hi. Mustafa, yeah. So yeah, just typing in the question or not? I don't know. Mustafa, let us know if you are still typing a question. We can still be here for 5 more minutes or 10 more minutes. I mean, it depends if there are more questions or not. As I said, this would be available on demand also. Okay. Well, it looks like these 22 questions, they're all, I don't know if we are, I think we replied to all of them. Let's go back and see if we missed something, but I don't think so. I think we replied all of them. I was replying some while Dean was presenting, so those were answered already here. And so there's something else here. Great present, Eileen. Oh, thank you, Eileen. And
that's a good question. And maybe I actually let me see if I can just take a minute here to go to my desktop and hope where
you can close it. Yeah, just exit there.
Oh no, it's okay. And then I'm just trying to recall, that would be in where would that be in the book here? We had something that was nope, it's not, wouldn't be there. Might be too ambitious to try to find that. Time slices. Let's just see if we have something that explains this. Well, yeah, zigzag non-reciprocity, I called it, which is a kind of a word that, even though I wrote it in a book, I didn't use it very often because it was kind of a nefarious kind of word. But you know, going in two different directions on a site, or on even on a structure, you'll get two different profiles. They're not symmetric, and that has to do with the fact that you have a transmitter and a receiver that are separated horizontally. And if they were co-located, then going in two directions, you'd get the exact same profile, but you don't get that because they're separated. And here's actually a simulation that was made off this structure, and we have the transmitter and the receiver going in two different directions, and you get something that looks a little bit different. And you know, part of that reason has to do with this right here. You have you're in the same location right here on the ground, but you have the transmitter on this side, and depending on how big your beam is, you don't hit this object. Whereas going in the opposite direction, you'll actually hit that object at the same location, right? If you had a narrow beam like this. So some people would say that by going in two different directions, you still, or zigzag, you record all the different features in that ground, even though they're not identical line to line. Some people prefer to go back to the beginning of the line and collect data so that they all have the same characteristics. You can actually sometimes see what kind of looks like an artificial staggering in the data, even though the positions are slightly changed because you've done a zigzag survey. It depends how much homogeneity you want in your images compared to imaging both sides of an object, which you can't see if you're going only in one direction. So there's a trade-off in both ways. And in terms of people that have a lot of field work, I would click data in the zigzag mode. Yeah. And because you're going to go at 100 meters and then come back to the beginning. That's crazy. But you know what some people would do? And I think it was the people at the University of Vienna, the archaeological group under Neubauer, they would often go to a site, they would do a zigzag survey, but they wouldn't rotate the antenna. So they would keep the antenna and then come over and come backwards. Yeah. So I would say just there is no exact answer to your question, but doing a zigzag survey, you can record both features on a structure at the same time at giving up a little bit of homogeneity to your image.
Okay. Yeah, thank you for sorry about that long explanation. This is the iPad. Can we import LiDAR topography data into the software? Well, yes, if it goes into the topography.dat format.
Yeah,
yes.
Yeah, it's just X, Y, Z. Unfortunately, OpenGL does not read a point cloud. You can't have a point cloud inside OpenGL. That'll be something that will eventually be put into GPR Insights when they start releasing their 3D modules, hopefully sometime in summer or a little bit beyond.
Yeah, or total station data. Yes, also total station data is possible. Yeah, also in insights you can import data of any manufacturer that has GPS or total station data. On 1.3 it's available. I think let's see.
Thank you.
Yeah, our data. If you do processing GPS lives. Well, yeah. Let us know. Maybe you can send us the.
Well, to do a zigzag survey, it's really simple. You get out of there. Just go to your treasure menu real quickly, and you collect data in the zigzag, and you just come here and decide which ones we're creating in the opposite direction, either the first ones or every other one, or based on some distance. And you hit start reversing, and this will reverse all your profiles in the radar folder. So that's all you need to do, the zigzag correction. So it really takes a second. Use the reverse menu.
Can you share the title of the book?
Well, I sure can. If you do buy the book, I think I get about 50 cents per copy, maybe. And it's available on, I think, on Amazon. Where is it? GPR remote sensing in our. Where is it? It's available right here. Springer or on Amazon, you can find it as well. It was written with my colleague Salvatore Piro from the Consiglio Nazionale della Ricerca in Rome, and Salvatore and I got to work together on so many sites over the years in Italy, and it's fantastic working with him.
Is GPR SIM also now part of Screening Eagle? Yes, is part of Screening Eagle. When is the next webinar? Well, yeah, we would love to have not a webinar, but a workshop, in-person workshop, as we used to do for many years in many different locations. And yeah, maybe in Spain, in Malaga, we have now an office there. That could be a possibility. And also in Asia, we would love to do one there, maybe in Singapore in fall. So we'll keep you posted, guys. In GS subsurface, I noticed ground horizon imaging migrated formates a block of red difficulty. Well, things related to the GS app, I think we need to take it separately. It's not on the scope of this webinar, but yeah, well, you're welcome to send me an email and explain this a little bit in more detail, so I can take it up with our team on the GS side. Any other question we have? Well, that's not too bad. 33 questions and only one about pricing is pretty good. Okay, so if there is no more questions, I think we can finish here. I'm gonna send the host. Any other comment from your side, Dean?
No, I'm just happy that GPR Slice has found a home at Screening Eagle, and I'll be around for a couple more years to make sure the transition is working, and of course to solve any new bugs that appear. It's been nice though. This year, I think there's only been 2 or 3 bug fixes, so things have gotten pretty smooth over the years. And I thank all of our previous users that stuck around with GPR Slice when we were in development, and you knew all the things that went wrong and went right with the software as well. There'll be a bright future through Screening Eagle with the GPR Slice, and I want to thank the team there for taking things over.
Thank you. Well, thank you everyone, and yeah, we'll see you soon.